To the video. In this session we are going to discuss about motion along a straight line motion, along a straight line. Okay, so let me reduce the thickness of the pen here. Well, very good. So now the question is, why do we study the motion along a straight line? So the question is, why do we study the motion along a straight line? Reduce it further. So we were discussing why do we study the motion along a straight line, or rather, why do we study the motion at all? Okay, so see, we study the motion because it is one of the most commonly occurring natural phenomena, and as physics is the study of nature, it makes sense to start our journey of studying physics with the study of motion. So what did we just say? That motion is one of the most commonly occurring natural phenomena. Okay, and since in physics what we study nature, so it only makes sense to start our journey of studying physics with the study of motion itself. Okay, you see, motion is such a frequently occurring phenomena that sometimes it is overlooked. Even the seemingly stationary objects, the keyword here is seemingly stationary objects, may actually be in motion. So what do we mean by that? See, take an example that you are in your study room. In your study room there is a table on top of which a book is kept. So this is the book, and you are sitting on your chair. So you may think that this table are stationary. So you may think that this is an stationary object, and you are right in your assessment. You may be right in your assessment since you are looking it from your room. But what happens when someone tries to look at the same thing from, let us say, outside of the earth? So this seemingly stationary object, this book, is actually moving. Why is it actually moving? Because it is on earth, and the earth is moving. So everything that is on the earth is moving with the earth itself. So the earth is revolving around the sun. Okay, earth is rotating on its axis. Okay, so there are two kinds of motion of the earth. So there are two kinds of the motion of any object that is even kept stationary on the earth. So this seemingly stationary object, this book, is actually in motion. So such is the importance of motion. So that's why it makes sense to study motion. Now let us come back to the question of why do we study the straight line motion first? So as in all other sciences, in physics as well, it is advisable to begin with the simplest of the things. So if we want to study motion, it is advisable that we start our journey with the simplest of motion. So as it turns out, straight line motion is the simplest of motions. Okay. So that's why we begin our journey with the study of straight line motion. So as we proceed, as we develop a very good understanding of a straight line motion, we have understood the various parameters associated with the straight line motion. Then we can actually add more complicated things into our study of motion. For example, we can add more dimensions. Okay. And many other complications in the motion. We can make our object to move along x and two axes or maybe three axes. We can actually try to study more parameters. Okay, and so many things can be done. But all of these things start with the study of the simplest one, that is the study of straight line motion. Now, the straight line motion can be in the horizontal direction, can be in the vertical direction, or can be along a slanted path. But the condition is that it must be along a straight line. Okay. So now we have been saying that we want to study motion, but we have not yet specified the motion of what. So that what is some object which we can classify as a particle here for simplicity. An object whose motion is being studied here is called particle. But how do we determine that object can be classified as particle? So a particle is a point-like object negligible in size. It is a simplified model of an object under study. Also, an object can be modeled as particle if every part of it one moment, if every part of it moves in same direction, moves in the same direction, and every part moves at the same rate. For example, a car which is moving along a straight line, the motion of this car along a straight line can be studied by modeling this car, which may be this size, like this. Okay, pardon my drawing. So this car can be actually modeled as a small particle for all practical purposes, because all parts of it move in the same direction. For example, if the motion is towards right, so all parts of the car will move towards right, and all parts will move at the same rate. Okay, so this car can actually be modeled as a particle. Now, when we say that we want to study the motion of a particle, we actually want to locate it at different points of time. So if we are able to, for example, in the case of this car, if we are able to say that this car is at position P1 at time T1, at position P2 at time T2, at position P3 at time T3, and so on, then we have actually located the particle at various points of time. Or in other words, we are able to tell about the position of the particle at various points of time, and thus we have described the motion. So that is all about motion. So now in the case of a horizontal straight line motion, so now we begin our journey of the straight line motion. Once we have described the various parameters like position, what is the meaning of location, what is a particle, so we have what is a straight line motion, we have described all of these things. So now let us try to understand with one example. So for the purpose of description, we begin our study by assuming that the motion is taking place along a horizontal in the horizontal direction along a straight line. So in such cases, we actually use an x-axis. Okay, actually use an x-axis with an origin as 0, and on the x-axis, the motion towards right, it's said to be in the positive direction, and the motion towards left is said to be the motion along the negative direction. This is the convention, and the unit here being used is meter. Okay, the unit here is in meters. Okay, so now we have described what is a particle, what do we mean by motion, what do we mean by straight line motion. Now we have also specified that for a horizontal line we are going to use the x-axis, for example. Now the next question is, how do we quantify the motion? That means, how do we measure the motion? How do we put numbers into our discussion? So one of the parameters, let's write down. Let me change the pen of the color of the pen. Okay, so here, fine. So it turns out that one of the parameters which quantify the motion is displacement. is displacement. Mathematically, let me reduce the pen's thickness. Yeah, that seems to be okay. So mathematically displacement is also, in this case, it is read as delta x. So delta x is equal to final position of the particle minus the initial position of the particle, or in a more concise notation, delta x is equal to xf minus xi. So where xf is the final position of the particle and xi is the initial position of the particle. So once we have defined the displacement mathematically, now let us turn our attention towards some of the key points about displacement. Okay, so A, if the motion is in the positive direction, or in a better way we can write, let me write down first. If the motion is in the positive direction, then the displacement delta x is then the displacement delta x is also positive. So this is a concise way of stating that if the motion of the particle is in the positive direction, then delta x is also positive, and if the motion is in the negative direction, then displacement delta x is also negative. So let us try to understand this thing with an example. So you see, if xi is let us say if xi is minus 7 meter and xf is minus 3 meters. Okay, so let us draw a picture to represent the data given. So we have this x-axis, this is the origin. Now minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, and so on. Similarly, 1, 2, 3, 4, and so on. Okay, so xi is, what have we said? Xi is minus 7 meter. So this is the position xi. Now the particle moves to a final position xf is equal to minus 3 meter. So this is xf. So you see, in moving from minus 7 meter to minus 3 meter, the motion is actually towards right. The motion is towards right, and we have said previously that when the motion is towards right, it is said to be in the positive direction. So what we have just stated, that if the motion is in the positive direction, displacement must be positive. So let us try to put these 2 points, these 2 values of the positions into our formula. So we have displacement delta x is equal to xf minus xi, which is minus 3 meter minus minus 7 meter, which is equal to plus 4 meter. So hence the displacement is positive. Okay, you see the locations both are in the negative direction. I mean the locations are both towards the left of the origin, but the displacement is in the positive direction because the motion is towards right on the x-axis. Similarly, we can take an example for the negative case. Okay. One more key point is that actual number of meters covered, during a trip is relevant as far as displacement is concerned. So what do we mean by that? So let us try to understand this statement with the help of an example. So let there be a particle which is at xi is equal to, initially it is at xi is equal to minus 2 meter. Okay, then it moves to, let us say, another point x is equal to minus 5 meter, and from there it actually turns back and goes up to a point x is equal to, so f is equal to plus 1 meter, and it stops there. So the displacement, as we have discussed previously, it is only concerned with the final position and the initial position. So the displacement here is xf minus xi is equal to 1 meter minus 2 meter is equal to plus 3 meter. But the actual distance covered is, let us see, in moving from minus 2 meter to minus 5 meter, the particle has covered a distance of 3 meters, and from minus 5 meter to plus 1 meter, the object has covered a distance of 6 meters. So the total meters covered is equal to 6 meter plus 3 meter is equal to 9 meter. Okay, so this quantity, that means the actual number of meters here covered in a trip is called distance, which is, this distance is another quantifying parameter for the motion. Okay, so we see that both distance and displacement may be quite different, maybe quite different from each other. Okay. So another point is that displacement is a vector quantity. Now what is a vector? Vector has both magnitude as well as direction. So how is displacement a vector quantity? Remember when we were defining displacement a couple of minutes ago, we actually needed to specify the terms like towards, right, or towards left. So there's a directionality involved here. Okay, so the complete specification of displacement involves telling both how far the object has been displaced, as well as in what direction it has been displaced. So it is a vector quantity, and as a matter of fact, distance is a scalar quantity. What do we mean by scalar? It only has magnitude. So distance is always positive, whereas displacement can be positive as well as negative depending on the direction in which it is the particle is displaced and our convention. So all of this example involves the use of x-axis. If the motion is along the y-axis, if the motion is in the vertical direction, we can choose y-axis. Other terms remain same. So thank you for listening to this, having a look at this discussion over the motion along a straight line. In this video, we have discussed what is a particle, what is a straight line motion, why do we study motion, why do we study straight line motion. Okay, we have defined what is a particle, we have defined the use of x-axis, y-axis, we have defined the terms like displacement and distance. We have also seen the difference between these two quantities. We have also seen that this is a vector quantity and this one is a scalar quantity. I hope this video has helped you in developing a better understanding of the concepts which we have just discussed. Thank you and see you again in the next